Hello, calculus kids. How's it going? What we're going to do today is we've been taking a look at derivatives and the derivative definition and how to use the limit derivative definition. So we're going to start off today with a little review of that definition. I'm going to define two terms for you, and then I am going to show you how to do some calculations, okay? How do we find the tangent line and how do we find a normal line? So let's begin with just a few quick things. So first of all, I do want to present to you my window. And what you're going to see is you're going to see my screen right here. And I'll try to enlarge it for you. So today we're going to talk about tangent lines and normal lines. So before we even get started, I would like to draw you a quick little picture of what they look like and what they are. And so we're just going to make a little graph. And the graph is just going to be some sort of continuous function. Okay? And then we're going to pick a random point. So I'm going to pick a random point right there. Okay? So what we're going to do is I'm just going to tell you or show you what a tangent line looks like. A tangent line is a line that crosses or touches that point and only that point on the graph. This is a tangent line. Okay? So the tangent line simply goes through one single point on the graph and it crosses through there. Usually it doesn't go through the function. It might go through the function, I would say, probably a little later on, way down here. But at this point, it just touches it, and that is all. The normal line, on the other hand, is the line that goes this way. The normal line goes through the same point, but it is at 90 degrees to the tangent. So the thing to remember is that these two lines are perpendicular to each other. Okay? So that's the first thing that you need to know, is you need to know what they are. So a tangent line is that slope, or is that line that goes through that single point. The normal line is the one that goes through the same point, but it's 90 degrees to the tangent. So let's do a quick review of the definition of, or the limit definition of a function. So a limit definition of, I'm trying to think of the word, the limit definition of a derivative. Thank you. That's the word. Let's go ahead. So let's review the limit definition of a derivative. Now, please remember that a derivative is simply the instantaneous slope at a point. Okay? So this idea of a derivative is the instantaneous slope at a point. It also is then the slope of the tangent line. So let's write that down. Okay? So what we're doing is this. It is the limit as h approaches 0 of f of a plus h minus f of a all over h. Okay? So let's just review how to figure out that slope of that line and at a certain point. So we're going to go through an example, and then I'm going to use that same example to find the tangent line and to find the normal line. So this is the example that we are going to take a look at. So we're going to have a basketball problem. It's just like the basketballs. Remember, in the basketball problem, there was an equation for the movement of the basketball. And that equation was this: f of x equals negative 16 x squared plus 594. Okay? So what it wants us to do is we want to find the slope, the tangent line, and the normal line at x equals 3. Okay? Now remember, x equals 3 means at 3 seconds. So this is the problem that we are going to take a look at. We are going to work our way all the way through this, and we're going to kind of go through how you do all of the parts. So I need to zoom back out just a little bit because we need a little bit of space. So the first thing we're going to do here is we are going to use the limit definition to find the formula, okay, for the slope. So let's start out with the limit as h approaches 0 of f of a plus h minus f of a all over h. Okay, so you need to remember function notation and how that works. So in our case, our function is negative 16 x squared plus 594. So here's what we have to do. We are going to find f of a plus h. So remember, in function notation, wherever there's an x, you have to substitute that value in. So it's negative 16 a plus h squared plus 594. That's this first part right here. Okay? Now, we do need to subtract also f of a. So remember, wherever there's an x now, I need to substitute an a in. So we're going to subtract, and then it's going to be negative 16 times a squared plus 594. Okay? Now remember, it's all over h. Okay? So, in order to use this definition, you need to, I'll zoom in a little bit for you. You need to just now do all of the simplification. Okay? So let's go through and let's simplify all of this. So we have negative 16a plus h. So we need to do a plus h squared first. Okay? So a plus h squared, and I'm going to just do kind of the math in my head. Okay? If you want to multiply it out, go ahead. But a times a plus h times a plus h is going to be negative 16. It's going to be a squared plus 2ah, okay, plus h squared, all times negative 16 plus 594. Now the other one is just going to be minus, and I'm just going to leave it all in here. It's just going to be negative 16a squared plus 594. Now, we need to go through and we need to kind of do some of our distribution and kind of remove some of these things. Now, I'm not going to put the h in on the bottom here until the very end. Okay? So let's distribute this. This now becomes negative 16 a squared minus 32 ah minus 16 h squared plus 594. And then I need to also distribute this negative to all of the things that are in here. So this becomes plus 16a squared minus 594. Okay? Now remember, it's still all over h, but we're not going to deal with that until we get to the very end. So now we need to go through and we need to cancel out things that cancel out. So you'll notice the negative 16 a squared, those cancel out. You will also notice that 594s all cancel out. Okay? And we now are left with negative 32 ah minus 16h squared. So we now have negative 32 AH minus 16 H squared. And remember, we still have it all over H. So what happens now? Well, we still can cancel out a few more things. We can cancel out an H out of each one of these. So we have negative 32A minus 16H. Okay? So that is the simplification part. But here's the problem. We need to find the limit as h approaches 0 of that function, negative 32a minus 16h. The only way to go ahead and do that is to do direct substitution. So we directly substitute 0 in for h. So this h right here is going to become a 0. So what are we left with? The derivative of the function, okay? And we're going to write the derivative of the function as f prime of x is going to equal negative 32 times a. And I'm sorry, this should be f of a. Is going to equal negative 32a. So that is the function that we use to find the slope of the line at any point. So let's continue.